Today's video is much like yesterday's, where we're adding sequences again, but today's sequences are geometric, meaning we're multiplying or dividing by a set number. Our beginning of our video here, again, is showing where our formula comes from. Our first formula, the one that you need to use to do sum of geometric sequences, is right here. So what we look at throughout is the proof of where it came from, because if we know our pattern here is increasing by our amount, multiplying by that ratio. If we multiply both sides by it, r on this side, r on that side, you see your exponents change. You can follow this through so you can see where the formula came from. But as far as our material, we need to know it's just the formula, not the proof. Once we have this formula is helpful like yesterday's, as long as we know what R, A, and N is. We can also derive a second formula, this one down here, for when we know the last term. So both are helpful in our questions. Our first example here, make some space. We know that we want to find the sum of the first 8 terms. We know it's geometric. We're multiplying by 2 all the way through, but we don't know the last term. So if we don't know the last term, this is the formula that's going to be helpful. So we have S at 8 is equal to A, which is the initial of 3. Our R means we're multiplying by 2 every time. Power N, we know that N is 8. We're looking for 8 terms, minus 1. Be really careful when you're dealing with these that your bed mass is correct, that you're doing your order of operations correctly. So what we have here is 3 times 256 minus 1 all over 1. And this gives us a final answer. S at 8 is equal to 756. So if I added up the first 8 terms of this pattern, the sum of it would be 756. So this example here, here's our second example. We now, this time, we know what T at N is, so we can use the other formula. S at N is equal to R times T at N minus A all over R minus 1. So here in this one, we're multiplying by 3 every time. So our R is 3. T at N, the very last term, is 4,374. I'll subtract A, which is 2, our initial term. So even though we don't know how many terms there are, we can still add up the sum in this entire sequence because we know the last term, T at N. And then R minus 1, which is equal to 2. So the sum of this sequence, when you follow your order of operations and complete the work, is 6,560. So if we added from 2, the whole pattern, to 4,374, this is what the sum of it would be equal to. Our work is here, and we will complete that in class tomorrow.